Hello everyone. Today it's the first day of our Arduino course. I'm going to show you how to give output on any Arduino pin, and I will start with some basics of electronic. So let's start. I will start with LEDs. What is LED? And how can we protect LED from high voltage and current? So what is LED? LED it's a device that emits light when an electric current flows through it. It has two leads or two pins. It has two leads, anode and cathode. Anode which is positive and cathode which is negative. Here is electric symbol. Anode positive, cathode is negative. It looks like a diode, but here the difference is in LED we have two arrows, but in diode we don't have these two arrows. How can we identify the positive and negative terminals in LED? So there is two ways. The first way is from the length of leads. The long lead is positive and the short one is negative. And the other way is we can look inside this epoxy case or epoxy lens. We can look inside this epoxy lens. The big flat plate is negative and the small one is positive. Sometimes these leads come with the same size or same length. So we can look inside this epoxy lens and we can identify which pin is positive and which one is negative. As I said, the big one is negative and the small plate is positive. Here is the specification of these LEDs. I'm using this kind of LEDs. The specifications here we have for the red, yellow, green and the blue colors. So we have all of these colors. The red one, the maximum voltage is 1.8, yellow is 2.2, blue is 3.6 volt. This is the maximum voltage which we can apply on LED. And the maximum current is 20 milliampere. 20 milliampere. I'm going to show you in the next slides how we can use this table. We use the resistors to limit the current through the LED and to prevent excess current that can burn out the LED. Here in this circuit we have here the voltage source, resistor and LED. The voltage source, maybe it's a battery, maybe from Arduino pin, maybe something from a different source. So but it's like it has positive and negative, so it's DC source. How can we calculate the resistance of this resistor? We can calculate the resistance from this law. Resistance equal the source of voltage minus the voltage of LED divided by the current of LED. Here we have an example. For example, if we have blue LED and the source voltage is 5 volt. So we need now to calculate the resistance of this resistor. As I said, from the specifications, I said here we have blue LED. If we go back to the table, here is the blue LED. The maximum voltage is 3.7 this amount of voltage which we can apply on the pins of LED, and the maximum current is 20 milliampere. Okay, let's use our law. Resistance equal, as I said, the source voltage, which is 5 volt here. It comes from Arduino pin, for example, or any battery, 5 volt, minus 3.6, which is the maximum voltage of LED, divided by the current of LED, which is 20 milliampere, but here we transfer it to ampere. So 20 times 10 power to 10 power minus 3. Here we transfer it to ampere, from 20 milliampere to ampere. So the resistance equal around 70 ohms. But in our practical circuit, I'm going to use 100 ohm because I don't have 70 ohm. Here is our scheme. We have Arduino Uno chip. Here I connected, as I said, I'm using 100 ohm resistor. I connected the pin number 2 to the resistor, and the resistor to positive of LED, and the negative pin of LED to the GND. Okay, here is our Arduino code. It's a flashing LED with 1 second delay. As I said here, before void setup, we can define variables or include libraries, whatever. Inside void setup, the instructions will run for one time. The compiler will run this instruction for one time, and inside the void loop, these instructions will run, the compiler will run them for infinity. So what is pin mode? Here, as I said, I connected my LED to the pin number 2. So I have to define pin number 2 as output. I have to define it as output. So we type pin mode, M capital letter. Here we open a bracket. Here the pin number, Arduino pin number. As I said, I connected to number 2, and apostrophe, then I can say its output. Don't forget to add the semicolon at the end of each instruction. In the void loop, I wrote here digital write pin number 2 high. That means I'm giving 5 volts on the pin number 2 of Arduino. So digital write, W capital letter, to the pin number of Arduino where I connected the LED. High, it means give high value on this pin, which is 5 volts. I can say high or I can say 1. So both of them correct. You can say high or 1. It means gives 5 volt. It means give 5 volt on the pin number 2. Delay for 1000 millisecond. It means 1 second. So here this number 1 second delay. Wait 1 second. Then digital write pin number 2 low. It means turn off the LED. Turn off the LED low, or I can say 0. Digital write pin number 2 0. This will give 0 volt on the pin number 2. Delay 1 second. And don't forget the semicolons at the end of each line. what I can do here, maybe I can define variable, I will call it LED 2. Here I defined variable, its name LED with value 2. So here I can edit. I can say instead of 2 I can say LED. Here 2 LED compile. Yeah, done compiling. Our code is correct. Why I changed my code to this way? If you have a big code and you want to change the Arduino pin, for example, I want to connect the LED to pin number 3. I will not go to each like instruction and change the number to number 3. So it's better to define a variable and call it LED, for example LED 1 or LED, let's keep it LED, and yeah, with value number 2. And here if you want, for example, I want to change it, I want to connect my LED to pin number 3, just I can from here type 3. So now it's already done. I will not go to each instruction and type 3 here, 3. Better from here, I can change only from this instruction. It will make the code easier for you. I will keep it now connected to number 2 and compile. My code done. It's done compiling. I will connect now Arduino through USB. Yes, it's connected now. COM number 4 Arduino Uno, and I just can say upload the code. Yeah, done uploading. Here is the practical part. We have Arduino chip, Arduino Uno, LED, 100 ohms resistor, and 2 wires. And this wire, the blue one, it's a USB cable. It's connected to my computer and to the Arduino. This cable for powering and uploading codes to Arduino. What else? Now I will show you the wiring, how I did the wiring. Here I connected the resistor to pin number 2 through the blue wire, and the other side of the resistor to the positive of LED, and the negative of LED to the wire, to the white wire, which is connected to the GND. As you can see here, the LED is flashing for 1 second, turning on, 1 second, turn off, 1 second, turn on, and it goes through this procedure. You can change the delay from the code, and the flashing time will be different. Here is the LED. As I said, look here, we have 2 plates. Big one is negative and the small one is positive. So also here the long lead is positive and the short lead is negative. Thanks for watching. See you in the next video. Bye for now.